about our shortcut for finding derivatives yesterday, but the big thing that you guys have to remember, it only works when we have terms added or subtracted. Okay, so if things are being multiplied or divided, we have to use algebra to simplify it first before we can use our shortcut. Otherwise, we're stuck going back to that old limit definition and working out your derivatives. So the big thing on that homework from yesterday, you might check them, make sure you have to simplify first. If you have a fraction, you cannot just do the derivative of the top and derivative of the bottom. It does not work that way. So make sure we're watching that. Let's look at this problem. I want to find the points on the curve where the tangent line is horizontal. All right, if the tangent line is horizontal, what is the slope? 0. How do we find slope of a tangent line? Which is another word for derivative. So we need to basically find where the derivative is 0. So the slope of the tangent line is y prime, and we need that to be 0. So y prime, using our shortcut from yesterday, derivative of x to the 4th. Minus derivative of 6x squared. And derivative of 4 is 0. So we leave that off. So I need to know when this equals 0. What did we factor out of here? Alright, so if we set this equal to 0, we actually get 3 different x values where we would have a horizontal tangent line. 0, positive radical 3, and negative radical 3. I asked for the points. What if I wanted the full ordered pairs? Could you guys give them to me? So I know my x's. Let's see if we can work it out. If you put a 0 into this equation, what do you get out? 4. So they would be from the original. So we plug in a radical 3. Radical 3 to the 4th. So radical 3 times radical 3 is 3. And so if you do that twice, we would get 9. Minus 6 times radical 3 squared is 3. So 9 minus 18 plus 4, negative 5. What happens if you plug in a negative? We get the same thing, don't we? Because a negative to the 4th is positive, a negative squared is positive, so we get negative. So if I ask for the full order pairs, you have to plug those x's into the original equation to get the y value from the original. Is that okay? Let's look at the next one. So this is the equation of motion. That's our position. Find acceleration. Okay, we have to think. So if you have position, how do we get acceleration? Right. We have the first or the equation, that's your position. First derivative is velocity. Second derivative is acceleration. Right. So let's find the first derivative. So from yesterday we know we bring down that exponent and multiply it with what's there. So 2 times 3 would give me 6t squared minus 5 times 2 would be 10t. What's the derivative of 3t? 3t to the 0, which is the same as 3. And the derivative of 4 is 0, so that's gone. That's velocity. We need acceleration. So second derivative would be minus derivative of 10t is just 10. So here is my formula for acceleration. And then I asked, what's the acceleration after 2 seconds? So what would we do? So 24 minus 10 would give us 14. Acceleration, it's centimeters per second squared. Unit. Those okay? Practicing what we did yesterday. So now we're going to start slowly every day from here for a long time. We're just going to be adding in more rules for derivatives so we can expand the things that we can easily calculate the derivative of. So we know how to do the derivative of polynomials or just numbers to a power. Next thing we're going to talk about is exponential functions. E, I've always told you, it's kind of like pi. It has a set value. That value actually comes from calculus. It is a specific number so that this limit would go to 1. We don't really need that. You don't have to know that. But that's where the E comes from. E is used very frequently in calculus when we're talking about populations and things like that. It comes up a lot. The graph of E, it's an exponential. We know exponentials always have a horizontal asymptote at 0. They always go through the point 0, 1. If you remember from college algebra, anything to the 0 power equals 1. If you take a positive number to a power, you can't get a negative, so they're always positive. They look kind of like that. With these exponentials, E is the one that has the nicest derivative, so that's the only one we're talking about today. And it actually is true that the derivative of e to the x is still e to the x. It is its own derivative. If we went through the whole process with the limit and worked it out, we would get to this point. Right, so here is my function. f of x is e to the x minus x. Let's find the first and second derivatives. So we know we can do the derivative term by term. What is the derivative of e to the x? Minus, what is the derivative of 1? Or sorry, of x? 1. Kind of did that one right. Okay, second derivative. What is the derivative of e to the x? Minus, what's the derivative of 1? 0. What would every derivative after this be? E to the x. Okay, I asked you to compare the graphs just so we can kind of see what these look like and what we know about our derivatives. So my first function was e to the x minus x. First derivative was e to the x minus 1. And the second derivative was e to the x. Okay. Kind of a lot there. So the blue one is the first function. You'll notice that function started out decreasing. So its derivative was the red one. And what was true about the derivative of that? It started out negative. So that red one started out negative. Here you had a horizontal tangent line on the blue one, so its derivative was 0. And then that blue one increased, so the derivative was positive. If we're looking at the red one, its derivative is increasing the entire time. So it's always positive, always above the axis. It was never had a horizontal tangent, so the derivative never equaled 0. So just kind of confirming what we've already talked about with these graphs. It's still true. Any questions there? At what point on the curve y equals e to the t is the tangent line. Anytime I see tangent line, what am I thinking? Derivative. Parallel to the line y equals 2x. What does parallel mean? Same slopes. So I'm saying the slope of the tangent line is the same as the slope of this line. What is the slope of this line? The equation is 2x, so the slope is 2. So what I'm asking you to do is find when the derivative is 2. So the derivative here. What is the derivative of e to the t? Still e to the t. And I want that to equal 2. How am I going to figure that out? It's going back to some college algebra there. Yes! Look at you. Since it's an e, we would prefer to add a natural log. And we know we can do it on each side. What happens when you have a natural log and an e? Cancel. So t is the natural log of 2. If I ask for an ordered pair, the x value is the natural log of 2. If I wanted the y, you'd have to put it back into the original. What happens when you have an e and a natural log? And we would get 2. So the actual ordered pair, if I asked for it. The x is the natural log of 2 and the y is positive 2. Right, we're going to do 2 more together, then I'm going to have you guys do a couple, and then we'll have time to work on homework. So if I asked you to do the derivative of this, before I do anything, we need to rewrite it. 1 over the cube root of x. How would I rewrite that? X to the negative, what power? 1/3. A cube root is an x to the 1/3. If you're bringing it back up to the top, we make it a negative. The others we can leave. So my derivative. X to the negative 1/3. So the exponent comes down. Keep your x. Subtract 1 from the power. So negative 1/3 minus 1. So 1 is the same as 3 over 3. So negative 1 over 3 minus 3 over 3 would be negative 4 over 3. Plus, what is the derivative of e to the x? Plus. This one is x to a power. So what do we do with the power? Comes down in front. We keep the x, and then we subtract 1 from the power. So this power is just now e minus 1. What's the derivative of e to the 3rd? It's 0. There's no x in it. It's a constant. So if there's no x, it's constant, your derivative is 0. So that is our derivative of this function. All right. Let's look at this mess. Where do we begin? Let's clean this up. This would be x squared times the cube root of x is x to the 1/3. This term is x times this, the square root of x cubed is x to the 3 halves. Minus the square root of 2 squared, just be a 2, x squared, over power to a power, that's x to the 4 thirds. Okay. When you are multiplying, what do you do with your exponents? Okay, so that would become x 2 plus 1 third. So 6 over 3 plus 1 over 3 is 7 over 3. Okay, this x, that's like 2 over 2 plus 3 over 2, so 5 over 2. And that's 2x squared. If I wanted to bring this up to the top, what would I have to make my power? So if I distribute that, what am I doing with my exponents? Since the x is written each time, we actually add those exponents. So, when I distribute that, 7 thirds plus negative 4 thirds, that would be 3 over 3, which is just 1. Right, this one, x, so we have 5 halves plus negative 4 thirds. We get a common denominator of 6. This is like 15 over 6 and negative 8 over 6. It'd be x to the 7 over 6 minus 2x2 would be 6 over 3 minus 4 over 3 is 2 over 3. So notice how much algebra we did ahead of time. So that now we can do the derivative. So the derivative of x is 1. X is 7, 6, so that would be 7, 6, x. If you subtract 1, 7 over 6 minus 1, 6. This one, bring down your 2 thirds, so 2 times 2 thirds is 4 thirds, x. 2 thirds minus 1, so 2 over 3 minus 3 over 3 would be a negative 1 over 3. First one, we're just doing our derivative, so you should get 10x to the 9th plus 7x to the 8th plus 4x to the 7th minus 35x to the 6th minus 0.33 times 6, 1.98x to the 5th plus 5 pi x to the 4th minus 4 radical 2 x to the 3rd, and the constant goes away. Do you get that one? Okay. Just keep in mind, pi and radical 2, those are just coefficients. And so when you do your derivative, the exponent just comes down and gets multiplied with those coefficients.
So we can't, like, I'm thinking radical 2 to a power.
No, the 4 is just multiplied, so it's basically 4 times the square root of 2. Alright, let's look at this one. So we have some different kinds of functions, so you need to rewrite them before you can really do your derivative. So a cube root, that's a 1/3. Does it really matter if you rewrite this one? No, because why? It's a constant. So what's the derivative of a constant? 0. If you did rewrite it, it's 2 to the 1/5, but it shouldn't matter. So exponent comes down, so this one would be 1/3 x to the negative 2/3, and that constant goes away. G, if you rewrote this, that would be x to the negative 3 minus x to the negative 3/4. So your derivative would be negative 3x to the negative 4 plus 3/4 x to the negative 7/4. You okay with that one? Last one. A square root is like a 1/2 power. When you're dividing, what do you do with your exponents? Subtract. So this is like 5 minus 1/2. So 10 over 2 minus 1 over 2. So you have x to the 9 over 2 minus 3, what happens with those x's? They cancel. Plus 2x to the negative 1/2. Does everybody know how I got there? Okay, here's another way of doing it. So we could write this as x to the 5th minus 3x to the 1/2 plus 2 times x to the negative 1/2, if I bring that up. Then when you distribute, you add your exponents. So 5 plus negative 1/2 is 9/2. Positive 1/2 and negative 1/2 is 0, so that x drops. And the 2x to the negative 1/2. Now we do our derivative. So we have 9/2 x. If you subtract 1, that becomes a 7/2. The 3 is a constant, so it goes away. Here, 2 times negative 1/2 would just be a negative 1x to the negative 3/2. Does that make sense? Last one. So this, we need to kind of clean things up first. So if I look at that, 2 to the 4th, so that would be a 16x to the 4th. So the derivative would be 64x cubed. Right here, this is the same as x to the 15th power, so the derivative is 15x to the 14th. So really trying to get you guys to practice simplifying things before. Let's go ahead and talk about number 4, but we are not going to do number 5, if that's okay. So this one, what would I have to do before I could work out my derivative? Yeah, we have to clean this. Oh, hold on. Let's ignore this one. I wasn't even paying attention. That's giving us a derivative and asking us to work backwards. I don't want to worry about that yet. Let's just ignore that. We'll stop there. Okay, so the homework is the second part. Add it to yesterday's, and then it will be due tomorrow. So you should only have a few problems.